In the grand tapestry of life, threads of mystery still linger, particularly when it comes to the enigma of evolution. This intricate process, a masterful chisel that has shaped every organism on our planet, has left an indelible mark on life's grand design. From the tiniest microbe to the towering sequoia, evolution's influence is undeniable. Yet its workings remain as elusive as they are fascinating. Despite centuries of study, there are corners of this field still shrouded in mystery, enigmatic puzzles waiting to be solved. Questions linger like whispers in the wind. How does evolution decide the path of life? What unseen forces drive its relentless march? These riddles have given rise to theories, conjectures that attempt to explain the inexplicable. Among them, two stand out, casting long shadows on the landscape of biological science. Today, we delve into the intriguing theories proposed by Lamarck and Darwin. Jean-Baptiste Lamarck, a pioneering French biologist, was one of the first to propose a coherent theory of evolution. In the early 19th century, Lamarck introduced a concept that had been long forgotten in the realm of science: evolution. His theory was based on two fundamental ideas: the principle of use and disuse, and the concept of the inheritance of acquired characteristics. According to Lamarck, an organism can change during its lifetime in response to its environment. This is known as the principle of use and disuse. If an organism uses a particular organ or trait frequently, it becomes more developed and stronger. Conversely, if an organism doesn't use a specific trait, it may weaken and possibly disappear over time. For example, Lamarck suggested that the long neck of a giraffe evolved over generations as they stretched higher and higher to reach leaves in tall trees. The second part of Lamarck's theory, the inheritance of acquired characteristics, proposed that an organism can pass these changes on to its offspring. That is, the traits an organism acquired or lost during its lifetime could be inherited by the next generation. To continue our giraffe example, according to Lamarck, the offspring of a giraffe that stretched its neck would inherit a slightly longer neck. Lamarck's theory of evolution was groundbreaking in its time. It proposed a mechanism for evolutionary change and argued that life was not static, but continually changing and adapting. However, it was not without its flaws. While Lamarck was correct in identifying that organisms could change in response to their environment, he was mistaken in believing that these changes could be passed on to the next generation. Genetics, a field of science that was in its infancy during Lamarck's time, would later prove that genetic traits, not acquired ones, are passed from parent to offspring. Thus, while Lamarck's ideas about evolution were revolutionary, they lacked the empirical evidence required to stand the test of time. While Lamarck's theory was groundbreaking, it lacked empirical evidence paving the way for a new theory. So, stay tuned as we delve into the compelling theory that revolutionized our understanding of evolution, brought forth by none other than Charles Darwin. Enter Charles Darwin, a naturalist who proposed a theory that has become the cornerstone of modern evolutionary biology. Charles Darwin, an English naturalist, embarked on a 5-year voyage around the world in the mid-19th century. His observations during this voyage led to the formation of his revolutionary theory of natural selection, the idea that has shaped our understanding of life on Earth. Darwin's theory of natural selection is built on two key concepts: variation and selection. First, let's tackle variation. In any population of organisms, be it a flock of birds or a colony of bacteria, there exists a natural variety in traits, from the color of one's feathers to the speed at which one can metabolize sugar. These variations are not random but are a result of genetic differences. The second key concept, selection, is where the environment steps in. In the struggle for survival, the organisms with traits that give them an advantage in their particular environment are more likely to survive and reproduce. This is what Darwin referred to as survival of the fittest, where fittest refers not to physical strength but to suitability for the environment. So, what happens next? The advantageous traits being linked to their bearers' survival and reproduction are likely to be passed on to the next generation. Over time, this process can lead to the development of new species, as those with certain advantageous traits proliferate and those without them diminish. This was a radical departure from previous theories of evolution, including Lamarck's, which proposed that organisms could acquire or lose traits within a single lifetime and pass these changes on to their offspring. Darwin's theory, however, painted a picture of evolution as a slow, gradual process occurring over many generations, with natural selection acting as the sculptor, subtly shaping species in response to the demands of their environment. Darwin's theory, supported by a wealth of evidence, has stood the test of time, yet it continues to be refined and challenged, reminding us that the journey of understanding evolution is far from over. Understanding these theories not only gives us insight into life's history, but also its future. The implications of Lamarck's and Darwin's theories stretch far beyond the realm of biology. They permeate into medicine, enabling us to comprehend the spread of diseases, resistance to antibiotics, and the development of new strains of viruses. In conservation, understanding evolution helps us predict how species might respond to environmental changes, guiding our efforts to protect biodiversity. It even gives us a framework to understand ourselves better, our behaviors, our culture, and our society. These theories also remind us that knowledge is not static. Just as species evolve over time, so does our understanding of the world. As we learn more about the intricacies of evolution, we refine, reshape, and sometimes completely overturn our previous ideas. So as we continue to unravel the mysteries of evolution, we're reminded of the ever-evolving nature of knowledge itself.